Hello, Alex.
How's it going, Alex?
It's going well. Yeah, really looking forward to this week's episode.
Oh my gosh, man. The between Kerbal, kind of her threads that she was going through around Power Query, and then some of the things that we had also taken back from the community. I mean, we have like a laundry list of things that we need to talk about.
No kidding. No kidding.
I'd be curious though, kind of from everyone else, was there any topics, at least around Power Query, that maybe you just like fire off in the chat? Let us know that we can kind of hit home on today. I think we saw like a lot of what we would call like reality product, and then also like the expectations that we want to hit home on. But seriously, it's your time. Anything you'd like to kind of answer. Definitely why we love Power Query. I'm gonna start out with that. Just like we're not here to bash on it in any way. We would love to see it get better, obviously through diagnostics and testing. But I don't know.
Yeah.
Your thoughts, Alex?
I mean, the thing I've been thinking about so much this week is how Power Query is different for everybody. And whereas everybody needs to use time intelligence and make a bar chart, everybody's Power Query experience is completely different. Yeah. And that means that people's feelings, how frustrated they get, whether they use it at all. I think I said before that because our team is trying to do like a synced data warehouse, they're not allowed to use Power Query. They have to do it in SQL and then load tables as is. I wouldn't recommend that unless you're trying to do exactly what we're doing, but like everybody's Power Query experience is different.
But that goes back to like the whole like query folding. Like if you're just doing a straight read of a product, like you don't have to use the graphical user interface. You're just connecting to it, running the query against the view, and that's it. Like there are opportunities where you don't even, I don't know, maybe you're like not even aware that you're using Power Query if you just press the load button.
Yeah, I think I wrote in our notes, you can have a great Power BI experience and never use Power Query. But you cannot have a great Power BI experience and use DAX or the visual canvas. Like, it just doesn't make any sense.
So knowing that we can't see kind of like the underlying queries, if people can get it loaded into their model, they're just getting it done right. Whether good or bad, or I think we'd also talk about maybe it's taking 2 hours to refresh, where really if they went in and tuned a few things, it could just take like 2 minutes.
Right, absolutely.
Those are the things that people are posting out in the message boards.
Right, and I think the other thing that can be frustrating about as a Power Query developer is if you make that 2 hours to 2 minutes transformation, does your boss notice? I don't know. Maybe. If you make your DAX from 200 milliseconds to 100 milliseconds, you bet he's going to notice. Which is not to say we're here to say you shouldn't invest in Power Query. That's, I think, sort of the opposite of where we're going with this conversation. But we wanted to talk a little bit about our thoughts about why it seems less exciting on the surface.
Just crazy.
Yeah.
I don't know. And then Laura had a great comment here. They notice, especially when it comes to premium capacity, 100%. So especially as we start thinking about premium usage and kind of model refresh parallelism, like just on the P1, you can get up to 6 models refreshing in parallel. So ideally, you want to get those things just cranking as fast as possible. So that 2 hours that you could be stuck with inefficient Power Query, tune that. If it's down to 5 minutes, boom, just keep moving on to the next one. DAX optimizations here for kind of Donald. He's like, people kind of notice those just right off the bat. Those are the things that are impactful. Those are the front end kind of end user experiences. It's really going to be like the back end folks, whether it be premium capacity admins or your DBAs who are saying, hey, let's fix that. And I had a few of those comments this week too. But let's go ahead and at least talk about kind of some of the key strengths and also some of the maybe gaps that I kind of see. If you don't mind kind of shooting over to my machine.
Yeah, let's do it.
Awesome. So I'm a huge fan of just obviously blank queries. I'm from a different era. And I'll kind of ask this to the chat here too. When did you learn Power Query, and then who did you learn it from? Like, I am an M is for Data Monkey guy. I learned it from Ken Poles. I was hardcore into VBA for writing Excel kind of automation and doing all my kind of data cleansing. But it seems like that is a bygone era, because we didn't have IntelliSense back then, so we had to learn everything by reading through the MS Docs, kind of getting our hands on the keyboard and just being frustrated. Alex, how did you come into Power Query?
Yeah, so I actually came to it all on my own, and I didn't really start getting into materials besides looking up individual blogs for individual questions until a couple years into it. I was doing Visual Basic development for environmental chemistry lab data entry, and we had like all these like forms, and we were using Visual Basic to rearrange the data, and so I started playing with Power Query to do that. But I did it all on my own. Didn't even realize there were folks that would teach me how to do it. So, yeah, a lot of folks are talking about Chris Webb's first book, which I think Chris is not super excited to promote these days.
I've read through the book, and I would agree with him. It's extremely dated, but the parts where he does like talk conceptual or even just kind of Power Query M, those are still fantastic chapters that hold up over time. Gil Reviv's book, if you're kind of looking for some of the more modern stuff, he does a lot of Power Query M and kind of a lot of conceptual ideas too. I think that one will probably hold up a little bit better. But
Yeah,
I'm still just
that's
like
the
waiting
book I
for.
ended up buying.
Yeah, I'm still waiting for just like a pure cover to cover, just Power Query M. I don't know that we'll see that just yet, and maybe we won't. We don't need it, because I think that's something we also talk about in terms of like looking at different people. Some don't even have the formula bar enabled.
Yeah,
Never seen
absolutely.
them. They don't even know it exists.
Right, when you open Power, I taught an hour-long course on Excel for people managers in our organization last month, and it was mostly Power Query. And when you open up Power Query by default, there's no formula bar. You don't know that you're actually writing code with buttons. But one of the great things that you do get, is if you do the steps in the wrong order, Power Query is very forgiving. If you go watch Chris Wagner's Power BI design streams, it's just constantly like, oh, I need to do this before this, and if you may not know this, but if you set this up first, you're going to save yourself a bunch of work later on. Power Query is not like that. Like, if you forget a step, you just click back in the order of execution and do it.
Yeah. So I'm going to talk about one of my kind of injustices here within Power Query, and obviously just something I would love to see fixed. Yeah. So right now I just went through all the functions that are currently available. I'll retrace my steps here. So I did our hash shared. I converted record.toTable. I'm just a weird guy who likes typing it out as opposed to doing multiple clicks. Extracted the prefix here. So GitHub.contents, GitHub, LinkedIn.sales, LinkedIn. I'm going to go to let's do table here now. So table or tables, apparently. That's even better. 106 rows. So I'm going to zoom in here at the very bottom. 106 rows. Yeah. This is table, right?
Yeah. Every time you zoom, Teams has a little bit of a hiccup, so just make sure to pause.
All right.
But yeah.
So right here at the very top, transformed, our table group. 1, 2, 3, 4, 5.
Yeah.
I've got 106 functions, and I've got 5 buttons.
That totally works.
It's kind of interesting. Obviously, here on the home, we've got a little bit more, right? So I've got maybe like producing rows, which obviously table dot first or last. But it doesn't tell me that these are table functions, right?
Yeah.
So that's confusing to me. That's why I have to run, and that's why I have to go in and kind of see here now, like, oh, I need to actually start learning kind of this Power Query M, learning all these different functions that exist. It's just, that's a kind of an interesting kind of pain point for me.
Yeah.
And then kind of hear from the comments, no undo though, kind of learning in Excel. And I would agree, I started out in Excel as well, so for me it was just more of the natural kind of transition over here in the Power Query and the Power BI side. there's not too many differences. Obviously, just maybe some namings and a few buttons that are kind of moved in different positions. But
yeah, the biggest reason I switched over from Excel to Power BI was actually I could save my work as I went. In Excel, you have to commit your Power Query changes before you can save your file. And you can't have Power Query open in multiple workbooks at the same time.
yeah,
And so that got to be really frustrating after the, 10th time I lost my work. Especially because back when I was doing it, Excel had a lot of stability issues. It seemed to have been ironed out, although I don't abuse it like I used to.
yep.
And that was the big reason I switched over.
And they're closing that gap in terms of like parity,
Yeah.
but it's still a vastly different experience. Like some of the Power Query over in Excel is like blazing fast. Where maybe on the Power BI side, because it's got the whole VertiPack, kind of just loading into that kind of single destination as opposed to like the worksheet layer.
Yeah.
I think Ken Poles does some awesome kind of performance timings that he's kind of shown. It's like, oh, yep. And for me, that's always like the interesting part too, and something that you and me have even kind of alluded to here recently is just Power BI forces people to use Power Query, or at least on the Excel side, people may not even know that it even exists. But they're still getting their work done over there.
Yeah.
And what kind of kills me here is I see them just loading in all this data in Power Query, and obviously they don't understand anything about kind of compression and the whole modeling aspect. So when they land into Power BI, they just throw on a flat table and they ask, how can I export this to Excel?
Yeah, absolutely. So one of the things that I wanted to make sure that we chatted about a bit was going through some of our we sort of made a list of all the different types of personas that experience Power Query, just to sort of think about all the different ways that people experience it. And I think it will be illustrative to everybody else too, to go through that exercise. So
yeah,
some of the things we came up with, we already talked extensively about the never enabled the formula. And we've talked a bit about Excel users that may have been using VBA, and their frustrations are, the window locking, trying to get their Visual Basic and their Power Query to play nicely together. We got a bunch of folks commenting on that. We've got, old school data warehouse and SQL developers that, their perspective is like, man, Power Query can't do joins, and like, why don't I just do this in SQL? And, can I type in a native query and all of these things?
but the native query is where I see the biggest points
Yeah.
of frustration.
Absolutely.
Because they write the native query and then they start doing the Power Query transformations on top of it.
Yeah. And it just falls over.
Yes.
This is really the big. We alluded at the beginning about how you can have queries that can go from running at 2 hours to 2 minutes with a little optimization, and this is really where it happens. If you've got a native query and then you stack a bunch of otherwise foldable transformations on top of it, you could have your little Power Query 250 meg container churning away at some transformations that your SQL Server already has. Maybe it even has a materialized view ready to go. And if you had just done connected to a view, it would have given you the answer in seconds.
But especially thinking about like foldable versus non-foldable, there are certain things, at least in Power Query, that should fold that don't.
Yeah.
They're frustrating for me, especially having kind of worked with the community on the 30-day challenge there. But the mashup engine gets constant improvements.
Yeah.
So if you see the data gateway kind of, being published kind of monthly, they'll say this is now in parity with the current version of the mashup engine.
Mm-hmm.
So that's where, hey, if I do Power Query right now and maybe something doesn't fold today, that doesn't mean it can't fold maybe in 3-6 months.
Right.
Whatever the case may be, in terms of like future releases. But that's where I'm going native as much as possible. Like, it's great if you have SQL and you want to write it, but store that in a view on the database side.
Absolutely.
And,
if
I think one of the things that we'd also talk about was just like foldable versus non-foldable experiences.
Right. So we've talked about a bunch of Power Query personas, but every organization's characteristics also drives. If you've got a really high quality data warehouse and all you really need to do is filter, you're going to have a great time in Power Query. But if your organization's data source is just a cube and you're trying to build different cubes in Power Query, like this was my experience for a long time. Like you are going to have an awful, time-consuming, slow-moving experience of trying to figure out how to orchestrate multiple data flows and split things up. And if you're working with the web, it really depends. If you're working with flat files, as long as they're small, probably Power Query is really the tool for you.
That's right. I love Laura's comment here. She just buys her DBA's coffee.
Yeah.
Make sure that she can get as close to the source as possible here with views.
Yeah, that's also really good. But again, though, for a while, I had the experience where they're like, "Oh, that data's in the cube. You should be able to get that." You're like, "Yeah, you're right. It's in your cube, but that doesn't do me much good."
Yeah. Oh man! All right, what do we have here? Kind of our legacy Power Query users, right?
Yeah.
They remember a time when IntelliSense wasn't a thing. That is from my era.
Mm-hmm.
Like, I've been around it long enough where I just had to learn the language, kind of read through the technical docs.
I think they didn't even have word wrap either, and so you'd get Power Query lines that were longer than you can imagine because they just spash in a bunch of GUIDs and file paths and just keep going and yeah.
But I think what you'll see there, especially from like the Chris Webb's, kind of MK, Feldman, Miguel Escobar, he's fantastic,
Mm-hmm.
and Ken. It's people who were pretty early on in the adoption, but they were also like forced into kind of learning the language at a much deeper level than currently exists, kind of either through IntelliSense or just some of the like AI functionality that now exists, at least within the ad column, which is great. If people can get it done, that's fantastic. And like, why shouldn't we encourage them to do that outside of the formula bar or outside of having to write custom code? But as I kind of showed, like the table example, like 106 options, we have 5 buttons. Like, when are we going to update the Power Query ribbon? I don't think that it's kept up to date with kind of the developers.
Yeah.
And I think we're starting to see that too, at least in terms of like DAX Studio and Tabular Editor and really empowering people. There's not a good story there, at least on the Power Query side.
Yeah. So Fernando has a question about asking questions, and the answer is feel free to write anything in the chat, and we will promise not to make fun of you. We will probably answer your question.
Yeah. And then Mark Walter here would love to be able to find and replace in the editor. Yes. I think I've seen people also mention like being able to, under query pane, just like sort ascending, descending, like these small little quality of life improvements that would be fantastic for kind of deeper developers, but you're just not quite there yet.
Yeah.
And then kind of super users, kind of our last one here, just people that contribute to the community. I'll kind of go back to Miguel, but I love seeing that he's an MVP. We're able to kind of get that clarified and rectified for him. But he's got some fantastic custom connectors out there that he's built. I'm thinking like the Power BI REST API connector. I know he's got like a YouTube one that he's built kind of in the past, but those are people who are at kind of that next level that we're all kind of like aspiring to be. But with data flows and other things, it's like, well, do we need custom connectors anymore, or would it just be better to land it in the data flow?
Yeah. I mean, custom connectors, like custom visuals, are tricky because on the one hand, they can solve a lot of problems. For example, you and I were looking at this XMLA endpoint challenge the other day, and we were running into some auth issues. And if we had been willing to take the time to write a custom connector, we could have solved those problems.
But a custom connector requires the data gateway.
Yeah, that's
it requires a lot of things.
And that's a big challenge, especially since we were trying to connect to the XML endpoint in the Power BI service. I don't even know if the data gateway really would have done that.
Theo had a great question here. Anyone else feel that the PQM documentation isn't as complete as it should be? 100%. There are some times when you go there and you look for examples and there's nothing. And the actual documentation is just the name of the function, and maybe it gives the arguments if you're lucky.
Yeah.
But they just did a massive kind of improvement over there, at least in Power Query and Dataflows. I want to say maybe a week or two ago, right? Reza Rad and Miguel had just contributed.
Yeah, I saw that Reza had been brought in as like a documentation consultant, which is awesome. Yeah.
So let's get into...
And also the other plug is that the docs are open source on GitHub. And if you want to go to the docs GitHub and write documentation, Maggie will review your pull requests and add things to the docs as appropriate. Doesn't happen very often, but I did it once before.
You got your little bubble in there. And then Laura had said, yeah, it would be great if we could submit examples to the docs. I would agree. Anything that could help out the next person, we should all kind of strive to accomplish. I'm gonna ask like flat out, like, I'm just curious right now. Is there anyone on the Power side, so the Power platform, that has started using Power Query over there? Because I feel like the only people that are talking about it are still Excel or Power BI users. So is there anyone with Power Apps or Power Automate that started using Power Query? And then also just anyone maybe within kind of the Azure Data Factory. Has anyone started doing the wrangling data flows? Kind of so the massive scale data transformations within Power Query. Because I feel like it's still just us in the Power BI, kind of the Excel side.
Yeah. I know our team looked at using wrangling data flows, but we decided we were just going to write Spark SQL instead. Because wrangling data flows in the back end, it translates it into Spark and runs it against a Spark cluster.
Yeah.
That would have been, I think, cheaper because we're running our Spark SQL on Databricks, and I think you would end up paying less in Data Factory. But yeah.
So Laura said, yeah, she's using Dataflow into CDS for Power Apps.
Yeah.
That's great to hear.
And I think...
So, I mean, people are starting to branch out.
Yeah.
So, I mean, in terms of like that transferable skill set, but I still don't see enough.
Yeah, I went and sat in on Chris Wagner's Power Hour at Rockwell Automation last week, and they've got a very vibrant Power Apps community, and they definitely have folks using Power Query for CDS over there. I was pretty impressed with how many folks were using Power Apps on that call. So,
yeah. Oh, should we jump into maybe data flows?
Yeah, let's talk about.
Any other topics to kind of go through the list?
I think one of the things that we should wrap up before we go over is we've talked a lot about gaps, but there's actually a couple gaps we haven't really talked a lot about, which is once you've got a data flow in production, the diagnostics you get when you have errors are pretty poor. You get error messages from the service, and you have the diagnostics you can turn on in desktop. But if you're having an issue that doesn't present in desktop, trying to track it down is really hard. I was working the other week on an issue where I had, 10 different data flows that were all appending into one output. And so the data flow would fail, and I'd get an error that the output query would fail. No idea which of the input queries was having an issue. All of their previews evaluated just fine. So that's another gap. So all this to say is that working with Power Query can be extremely frustrating. But that said, I mean, we're all here talking about it because we're all convinced that it's possibly the best piece of technology Microsoft's developed for combining multiple sources and like bringing it all together. Like, there's a reason why we put up with so much frustration and have so many examples. It's because like there's no better choice unless all your data is in SQL.
I love that.
Yeah.
Because that's something that if you got a chance to watch Reed Havens' Microsoft Power BI channel, kind of conversation around Power Query, I want to say it was maybe a week or two ago.
Well, Reed just said he only needs 5,000 rows, so I'm gonna take that with a grain of salt.
But I loved his conversation, and I could see it coming. I could see them coming in the chat. It was basically the people at the very end who said, "Why should I learn Power Query when I know SQL already?"
Yeah, I mean, my thought.
That crowd exists. And
yeah.
they don't see the benefit of Power Query.
Yeah, and if you already have a SQL Server where you're paying through the nose for the cores, not that you don't pay through the nose for Power Query or for Power BI Premium, but if you've already got a SQL Server and you write good queries and you have clear path to ingest all your data to SQL, that's great, you know? But if your data is not all there, using Power BI Pro is going to be much more cost effective for ingesting that Excel document than trying to use SSIS to move it into into SQL and then write SQL. Like, yeah, if you've got a very mature data estate, you might be able to get away with just SQL. But if you change jobs, there's a good chance that they're not mature. And Power Query is going to be a really great way to bring all that stuff together. So yeah, like Adam says, you're always going to get the best performance the closer you push things to the source, but you can't push things to a text file.
Yeah. That's where, like, I would rather learn the language. I mean, for me, it can do REST API calls. Obviously, you can do kind of fold in here if it's against a kind of a relational database source, connecting to, Excel, just flat files, text, CSV. One language that can connect to anything, that can do anything, that can do iterative looping. Man,
yeah.
I would rather go native. And then the fact that it's found in nearly like 12 different products at this point, this is where I'm just like, if we can copy and paste our M code from one solution to the next, to the next, to the next, obviously it's this whole like common data service, Dataflex, stories, coming together. I just love that I can learn one skill set and just be all over the board.
Yeah.
But let me jump over at least to Dataflows. If you want to go ahead and share my screen here, I'll talk about like right sizing Dataflows.
Yeah.
And then I'll drop this in the chat here as well. So kind of talking about diagnostics.
We might need to zoom in here, Alex. I can barely see it on my big monitor.
Just drop it in here. So this is premium Dataflow workload parameters configuration, kind of written by the Power Query team. It's extremely dry, extremely nerdy.
There we go.
You probably won't understand, like, I don't know, 100% of it because it's so weird and out there. It's something I never wanted to learn, never wanted to know, but here I am on the page. So we had talked about container size. What was the desktop limit again we had mentioned?
I think the default was 250 megs. So
256 megs.
What that means is that when your query is running, it'll use 250 megs of memory to hold the results. And if it goes over that, it will page the data to disk and do another 250 megs. So if you're trying to join two large tables, like you're just constantly going back and forth between disk and memory. And honestly, that's the biggest reason why queries can become slow. Even if you've got fast memory, so on Jeff Atwood's blog, there's a really great article that compares latency times to human timescales. And the difference between memory and an SSD is a couple orders of magnitude in terms of how quickly the CPU can access the data. And so when you're moving the data back and forth like that, to try and, iterate through a merge, you're really, you've increased your execution time by an order of magnitude, and it's not because your CPU is maxed out. Your CPU is sitting around twiddling its thumbs waiting for more data.
So let me scale down here. I'll kind of roll down. Talking about the container size, right? So the 256 that we kind of have in the desktop, at least within Dataflows, we can control this. So 700 megabytes kind of being the default. At the very bottom, they do have a calculator. So I'll go ahead and kind of scale this out. And we'll zoom in on this. So they've built this calculator here now for us. It's talking about front end versus back end cores. So just on like a P1 SKU for a premium, you have 4 back end cores. Then you have your working set size, so the total size of that container. You can do up to 4 max containers here now with that 4 cores. If we were to kind of scale this out a little bit, let's say 1,000, because we want to store a little bit more kind of data before we start paging it. Let's do 1,000. I now see that I only have 3 containers that I can use.
Yeah.
So I've got four cores, 1,000. I would still hope that I have 4, right? Well, no, because there still has to be logic for the Power Query M, kind of the mashup and the transformations.
Yeah.
So it still reserves a little bit of size for it.
Yeah. Now,
scaling up to...
you can increase that, I think, on the left, right, by increasing your max container sizes.
For these,
oh no! If you have to increase your
default.
max memory, that's the parameter.
Yeah, max memory. Yeah, but this gets into premium capacity management.
Yeah.
Do you want to run, let's say retail price $5,000 a month? Is that how you want to spend your premium dollars? Is purely on kind of this ETL?
Yeah.
Is Dataflows the best option?
Right. Or should you use Data Factory and run up wrangling data flows and pay by the minute for Spark to execute the same job? That's, going to be a tough... There's a lot more that goes into that. And you have a lot more power. One of the things with Dataflows, I think this is the biggest reason, Matthew loves to say that Dataflows does not replace your data warehouse. And we took a crack at ignoring Matthew's advice and using the common data service or a common data model to have it participate in our data warehouse. And it didn't really work out for us. But in Azure Data Factory, you get way more flow control. So kick off this job when this job finishes. When you get this event message, refresh this other thing. If rows fail, put them in a staging table and we'll come back and do some data quality checks on the failures. Like all that kind of stuff that like a full-fledged ETL job might want to do. You can do that in Data Factory. But on the flip side, you have to do that. Power BI will automatically retry when it fails. It's got all the auth stuff built for you. So, you're signing up for a lot more work.
Yeah, so let's connect out to just my favorite subreddit, Power BI, over on Reddit, and then just .json at the end of any subreddit, and it'll turn the thread into a JSON body. So I'll do next over here.
Well, Alex, now I'm going to have to stop using Reddit now because I don't like JSON files.
So we're going to connect out here, Power Query Online. So this is just Power Query up in the Power BI service. Point and click navigation here. We'll get to our data. Oh, Jason. I love that. All right, so let's go ahead and keep expanding out here. I'm not using any enhanced compute. I'm just leveraging, just the kind of native Power Query Online container sizes. Still getting closer, expanding records, data. I'll get there soon, trust me. All right, and let's go ahead and expand these out now. So press OK. I might have to remove a few of these. Let's do subreddit and self-text. So sub, Reddit, text. Did I not just click those? Yes, I did. All right, so we'll do remove other columns then. We'll take the long way. Add more steps here. All right, so I'm going to transform, set just the data types. This way we can go ahead and save and load this. Cool. So we'll do Power BI. Just as my entity name, save and close. And then the great thing with this is it's actually bring your own storage. So ADLS Gen 2. So I'm not leveraging Power BI because if you're using the Power BI assigned storage, only Power BI can access it. No other tool can. So right here, let's go ahead and save this. Validating queries. I know that's David's favorite screen of all time. It's just, he's got it marked up on his own pillow. sleeps on it at night. I know he always likes beating up the team there with that screen. Let's get this loaded, and then what we're going to see here when we go kind of this final state of save. I'm in Azure Storage Explorer. Kind of my Dataflows preview now. We're just waiting on this to complete.
So
there we go.
Alex, is this your own tenant? Did you have this set up at the tenant level, or is this the new workspace level that just came out?
This is my own personal tenant that I've attached to, but we can show that now, at least in terms of like attaching data lake storage at a workspace.
Yeah.
I still have some questions around that, and I don't know. I'd be curious what other people thought. So let's do Reddit. So we'll kind of save our data flow out here into our Dataflows preview. Press save. So I've got my Dataflows preview import. Yes. Go ahead. Now let's just refresh it now, right? So data lake storage, Dataflows preview import. So it's creating this folder now for me. I see this Reddit folder, right? So if I do close, if I just go ahead and hit refresh, refreshing my data, I can go into Reddit. I can see here it's created that powerbi.csv for me, and then this model.json. So I'll go ahead and zoom in on these now. So a data flow, it's just taking data from a source, right? In this example, I'm just stealing it over from Reddit in JSON form, and it's dropping it into a CSV, into a data lake.
Much better than
that's
JSON.
The magic, right? But that's the magic of a data flow, is it's just a CSV.
Yeah.
Like,
it is.
and then really all of the brains that are in here are model.json.
Right.
So let's go ahead and download this. I'll save this here in my documents.
So while we're bringing that up, David Eldersveld, I think that's right. Dataveld brings up, points out that he's still got queries that are validating from 2019, and that is one of the characteristics of Power Query. I haven't decided whether this is a plus or a minus, but every time that you add a step and it builds the preview, it doesn't take the existing preview and go ahead and transform it. It goes back to the source and fetches the data and reevaluates the query up to where it is, which is great because you know it's going to work. But if your query is slow, that means every change you make to your query is slow. And then when it does validation, what's going on is it needs to check the schema of the query to make sure, like, it goes and it runs, it wants to know what the column names and data types are. Well, if you're querying something like SQL Server, it can just run a metadata query that says, hey, like, I want to get the top 0 rows. But if you're querying a web source or a non-foldable source, it can't fold in a top 0 filter, or your CSV files, like, I don't know what that means, and just here's the file. And so getting the column headers can take just as long as running the whole query. So that's why sometimes when you're working in Power Query, it just feels horribly slow. And
yeah,
you
can kind of feel that sluggishness at times. So knowing that kind of with the data flows or working set size containers, things are moving slow, they're being sluggish. This model.json, though, is really kind of the full driver of the complete data flow experience. So remembering here, we called it Reddit. My individual query, so my entity was just called Power BI. I can kind of see this down here in my document. So I've got this full string. I see this let source equals json.document. All right, so that looks like Power Query.
Yep, that's your M. And just like the old school, there's no highlighting, there's no IntelliSense, there's no word wrap. It's great. A little nostalgic.
So let's go ahead. We'll drop this over here, and let's see how we do. We'll see if we can't format this here now. I have to zoom out.
Do you think it's going to handle those line breaks, or do you think you're going to have to clear those?
I'm had to remove those, yeah. So /r/n replace. Yep. All right, let's see how we did here. So I've got my let. I'll clean that up. Wish me luck. Wish me luck here. Very cool. Do format document. Of course.
You've got the # slashes as well as line breaks. I think those are, or no, the # belong, but the slashes after the # don't, right? That's escaping them as special characters.
All right, so let's try that then.
And
great catch, man. Two Alexes are better than one here.
Oh, you know what?
Nope.
No, it's not that. Look at the end of changed column type. It wasn't escaping the. It's also escaping the parentheses or the quotation marks.
Yeah. So let me just go back to the beginning here. Now I'll just kind of break out a few steps because I think we're good on some, but others just kind of suck.
Mm-hmm.
So navigation equals source. Yeah. You can see here it's just storing the Power Query logic that we have out in the model.json here. So it's just running these steps that we've now applied. Our entity, obviously, once again, is just titled Power BI.
Mm-hmm.
The location is powerbi.csv. So once again, the data flow that's landing in my data lake down here. Location, my DFS, core, powerbi.csv. And then here are my attributes. So the first column is called subreddit. The second one is called self-text. Obviously, just the data types are string,
Mm-hmm.
so just text.
Yeah.
So,
and
I'm using a data flow, but I'm leveraging Power Query.
Yeah. And the other really cool thing is if you want to give your users the data flow experience, but you don't want to use Power Query because you need to do some fancy incremental refresh or some of the flow control things, you can create these model.jsons and attach them as data flows.
So right here in data flow,
Mm-hmm.
attach a common data model folder. So that model.json, create and attach. It's going to ask for us to just insert this now. So this model.json here at the very bottom. So let me kind of what you're proposing. So I'm going to go back to just Power BI.
Look at this. I proposed something out of the blue, and Alex just has a demo ready to go.
I love it. So I'm going to go ahead and copy just the URL here. So I've got this folder now that's called colors. I've got colors.csv and then colors_2.csv. And then if I was to actually kind of look at this model.json, so let's see what this looks like. So I wrote my own model.json, colors, right?
Did you write this by hand, or did you use a script to generate it?
PowerBI.tips as a model.json builder.
Excellent.
Yeah. So if you want, obviously, just leverage Power Query if you want to, and then you don't have to use this document section. And we're going to show that here in a moment. So I don't have a document section over here, so I'm not using any Power Query. I see this colors table. I've got my columns here now, so my attributes, ID, int64, color, string, value, decimal, and then I have these partitions. So it's telling me exactly where I should point to find this CSV file. So this colors.csv.
Yeah.
So let's try this now. So we're going to attach just an external CDM folder. Go ahead and grab that over here. A couple little interesting, tricky things. So let me go back over here. Just attach external. I'm going to call this colors demo dfs.core. So I'm going to paste this. So I need to update, instead of saying blob, I need to do DFS. Then here at the very end, model.json looks good. Stock keeping %20s look good. All right, so let's do create and attach. Let's see how we did.
Though I have had problems where if you have multiple layers deep of folders, sometimes you have to massage the URL because it'll start escaping.
%2f, if you see that at the very end, go ahead and update that.
The slashes to URL format.
Cool. So Reddit, if I remember here, I've got these settings right. I can change the scheduled refresh of my data flow I can do anything I want, in terms of endorsing it here, if I want to promote it or certify it. Colors demo test, so the one that we just kind of put together, I don't have any options.
There's no edit button.
No. So let's go into settings. This data flow is hosted in external storage.
Yeah.
So I don't have any scheduled refresh. I can't, promote it as a certified. But what can I do? Obviously here is I can connect to this now. So this data flow can be edited because it's hosted in external storage.
Mm-hmm.
And then let me go ahead and try. So I'm going to go to my desktop. I'll be curious here if I can get to it.
Yeah, the other limitation is you can't use them in linked data flows. So
Yep.
I'm pretty sure you can make computed data flows, although it can be finicky for sure. But you definitely can't create a linked data flow with an external storage. Theo asks to expand on the difference between a data flow and a data set. So while Alex is actually, a data set is something that's created in Power BI Desktop, and the data is held in a analysis services database, which is a highly compressed in-memory database that's optimized for running queries that return aggregates that have relatively small row counts. A data flow runs Power Query, but instead of compressing the data into the Vertipack format, it just writes a CSV, which has almost the exact opposite characteristics. It's not highly compressed. It's not optimized for running queries or returning fast aggregates. However, what it is optimized for is giving you the entire table all at once, which Vertipack is uniquely bad at. And so data flows are created in the Power BI service. Data sets are mostly created in Power BI Desktop. The transforms, the Power Query that leads up to them is basically the same, but the output that you get is, couldn't be more different.
So in this example, we have a data flow, which is just a single table. I mean, that's it. There's no measures. There's no other, other fun things attached in terms of like relationships. It's just going to be a flat CSV.
Yeah.
Obviously, you can kind of enrich it a little bit within some of that model.json metadata. But in this example, I'm looking at a data flow entity here now, colors. I see ID, I see color, and I see value. If I want, I can go out and connect to that, and then just bring that data in. Here's my model. So we didn't use any Power BI premium capacity. We're not using, any like pro refresh. We're simply saying, here's my data stored in a lake. Here's how to go find it, based on the location down here within our partitions. So our colors.csv is where we're pointing it to. Now this is like great, right? If all we are doing is pointing to a single file every day, and that file is just being appended to, which may not always be the case though.
Yeah.
So if we had a colors.csv, we have this now colors.to. We can come over here, just kind of copy this. Obviously in this example, we're just kind of doing it manually. You'd want to script this out. But I'll say partition 2. I'll say this is now my second batch of colors. And the location of this is going to be colors_2.
Mm-hmm.
Colors 1 and colors 2. So I'm just adding a new partition here. So I can press save. I'll just want to go ahead and upload this kind of updated model.json now to my storage explorer. So let me find model.json. Here you are. Copy this over here to our storage explorer. We're going to update that brains here now. So our model.json. Pasting it. We're going to overwrite it. Replace. Apply all. So in my current file, I've just got kind of 1 through 8. Connected this data flow. Start here. But if we were to go out there and look again now, kind of with the storage explorer updating, yes, awesome. Data flows. So we got 1 through 8 at the moment. Pause to maybe go out and just take a look at the preview again, just out of general curiosity. See this loading, kind of our external attached CDM colors, and maybe I have to refresh this preview. All right, let me hit refresh on the model. All right, I'm just having a little bit of time there. Alex, go ahead and install for me, man.
Yeah.
Take.
So, one of the things that we've been doing with Dataflows is we've been mirroring our data warehouse into CDM folders. And the idea was to give the really nice Dataflows consumption experience from Dataflows, because our data warehouse is in Databricks, which is an amazing tool, but the Power BI connection experience is not super great. And so we had the idea that we could save it into CDM. And when we're done with this demo, we're going to talk a little bit about the enhanced compute engine and why it didn't end up working out for us. Theo asked a question about Dataflow security. So this is actually one of the really great things about CDM folders and external data flows versus using traditional data flows. So in traditional data flows, data flow permissions are synced with the workspace permissions. So you have admins, members, contributors. They can all query the data flows. And you have workspace viewers, and they can't query the data flows. And that's it. Every data flow in the workspace has the exact same permissions. Well, when you're using bring your own storage or external data flows, you can do additional security because Azure Data Lake Gen 2 has full POSIX compliant access control lists. And so each individual file can have permissions to users, groups, whatever. It's a little bit of a pain to work with because ADLS doesn't do permission inheritance in the way you're used to from Windows. And so you sort of have to plan your security setup out before you start adding the files. But you can control individual tables, and you can even control individual partitions in a way you couldn't with regular data flows. In terms of is it safe, it uses Azure Active Directory to authenticate storage, and when you're using bring your own storage, you're taking more responsibility with more control over who can access the data. You have more options to give too many people access, but it's as secure as anything else on Azure in terms of actually doing what you told it to do in terms of access. So yeah, we trust a lot of sensitive data on our data flows and external CDMs.
It's no different than kind of putting in the database layer, right?
Yeah.
Like you would rather have security closer to the source. So that way, obviously if Power BI is gone in 30 years, you're like, well, we still have security at the source. Now we're just going to attach to the new fun product, which isn't going to be the case, right? But here in this example, kind of the two different files, colors 1 through 5, colors _2, 6 through 8. I created my new partition here, so my two partitions now combine. I'm not expending like any Power Query in this experience.
Yeah.
It's like mashup containers. I'm simply just reading from the lake, reading from that model.json. Now, I would agree, Mark. It's not going anywhere anytime soon. And I think that the convergence here with the Power Query and Power BI over the kind of the past 5 years, I mean, this story is only getting better and better. Mm-hmm. What I would love to see, though, is just like a more clear defined path for when people can or should be using Power Query over in Excel, as opposed to just doing like flat file outputs over in Power BI Desktop in the tabular format. It kills me.
So, Alex, before we move off, I want to ask a question. Say I've got a Power Query that outputs 100 million rows. and my users want to build reports, and each of them want to filter down to just pull out 1 million rows from each one. How's that going to go?
Not very well.
Yeah. So.
Not very well.
Yeah. You've got the CSVs, and they can't be subdivided. So maybe if your user's query is nicely aligned to your partitioning, and Power Query can figure out what you're partitioning in, which is not guaranteed, they might get where they only have to download the data they need. But they're probably going to have to download the whole data and then use that 250 meg container to find the data that they're looking for.
Yeah.
Now, what you can do...
One of the big issues, at least with Dataflows at the moment, is just it can do a direct query of a read, but you can't do any additional transformations on it. So like a simple filtering for the data that you need, you're stuck in mashup.
Yeah. Now, what you can do with Premium is turn on the enhanced compute engine. And what this does is when you load your data, so not external data flows, but when you're using bring your own storage or traditional data flows, when you load your data, it will copy that data into a instance of SQL Server running on your Premium capacity. And then when you run queries, it can do query folding against that copy that's in SQL Server.
I love that you called out Premium. The attach external CDM folder, it is not a Premium only feature.
That's
right. You don't see any diamonds over here.
Yeah.
How I would manage my environment is, those like golden calendars, corporate calendars that we have. I don't want to waste my premium dollars or, my pro experience, kind of within the Power BI if I don't have to.
Yeah.
If that's something that everyone's going to use, I just want to create that as an external kind of attached CDM folder and then just let everyone start inheriting.
Right. And by the same token, my issue with the enhanced compute engine is that while SQL Server is a relatively expensive product, Power BI Premium is $5,000 a month for 4 cores?
Yeah. 4 backend, yeah.
That's I've heard someone say once those are the most expensive cores in Azure. So I don't want to run SQL Server to do ETL on those cores. I want to keep those for my analysis services workloads. So now it's different if you need Premium and you don't have enough work to fill up your CPU. But if you do have more than one Premium capacity, you definitely should think twice before you want to use the enhanced compute engine, because there are more dedicated services that are going to give you better cost ratios, or maybe even by the minute billing in the case of Azure Data Factory.
Yeah. So with ADF and kind of thinking about, where could we go with Power Query if you're telling me that I should invest my time into learning M and kind of performance tuning and querying? I love that they call them now citizen data integrators. So that's our title on the Power Query side. If you didn't know, you're a citizen data integrator.
Not citizen developers. They'd have to pay us extra for that.
So over here, obviously supported sources that is allowing you to read from, whether it be kind of a SQL database, if it's CSV stored over on blob storage. But you can now start doing Power Query kind of with Spark-based compute. So you can do massive data transformations here just through the exact same language, the exact same kind of user interface. And that's something that I'm most excited about here in the next semester. So this will take us through March 2021. Power Platform data flows grow up into Azure Data Factory. This link, the ability to further extend or optimize a data flow created within Microsoft Power Platform by the citizen user. And now you're starting to move over to Azure Data Factory.
And hopefully this means that they're going to get more parity in terms of number of connectors, because if you're trying to migrate, those limitations are going to be really tough.
Yep. And especially thinking about the container size, the working set size, we're oh my gosh, we just had to page everything. Spark-based compute support, so kind of coming next year.
That's going to be really cool. Scale. I really want to know when they use the word Power Platform, do they mean all of Power Platform, or do they mean what they usually mean when they say Power Platform, which is everything but Power BI?
Yeah, Yeah, so that'll be interesting because there's Power Platform data flows, and then there's Power BI data flows. It's like, let's unify that story. Let's make it a little bit less confusing.
Yeah.
Definitely things that I'm excited about that are kind of coming up.
Yeah.
The diagnostics, I know that's something that we should be looking forward to as well. Importing and exporting custom data flows templates.
Yeah.
So that way you can build something in the Power BI desktop, you can turn that into a data flow instantly.
Yeah. The other thing for creating external CDM folders, which we didn't touch on before, because we're right at time here, is that there are scripts that you can use to run in Python if you're using Databricks, or there's an Azure Data Factory to create a model.json dynamically from the schema of your data in your ETL tool. And so this is how we were doing it, where we'd make a bunch of tables in Databricks, and then we would run this Python script to create CDM folders, and it would iterate through the tables that we gave it, and at the same time that it created the CSVs from the tables, it was creating a model.json that matched the schema of what we were running out. It worked really well. Dave's post gives you the code to do it. We didn't have to write any code at all. At least any
this
Python.
This is a fantastic blog series.
Yeah.
If this is something you're interested in, kind of taking some of the data flows that are just consuming a lot of your resources and saying, well, all right, well, maybe we can look into this attached external CDM.
Yeah.
It's just a Python script that you attach to kind of that workflow, but it is incredible.
Yeah. Yeah. So yeah, we're at time here. I don't know if there's anything else that you wanted to cover before we end our official topic. I know as a preview, after we're done, am going to continue to stay live. I've got a really interesting data modeling problem, and I'm just going to work through it out loud, which I think might be exciting for some of you. So we're going to try it out.
Yeah, and I would say, at least for kind of the Power Query folks, kind of like me, where it's like, all right, I'm investing my time, I'm getting better at this thing. Obviously, diagnostic improvements should be helpful and should be coming soon.
Yeah.
Areas that I would like to see the gaps closed are allowing external tooling. That's just something where I think we would all benefit from, but just until kind of like the legacy architecture of Power Query is fixed, something we just have to be patient with.
Yeah.
And then also just like realizing the expectations of what you're trying to do. Don't try and overcompensate a bad data culture with a lot of Power Query transformations. Like if it's a slow Power Query experience and you're like, well, this thing takes forever. I don't like to see transformations where I scroll endlessly on the right-hand side in the applied steps. That just kills me. It's like, well, could we have a conversation to clean up the actual data source? If that's not possible, then I kind of understand just being empowered through this technology, but understand that at that point, it's a lot of limitations.
Yeah, that said, if you totally hit a wall organizationally, Dataflows is your best friend in trying to do something that everybody thinks you can't do or shouldn't do, or your sources analysis services.
Where it's like hours and hours.
Oh, yeah. It'll become your full-time job.
Yeah. So that's where it kills me. Don't try and overcompensate within Power Query for a bad data culture. Just try and correct those things where you can find them. Maybe it's people laying out their data in a more kind of readable format, or exporting to CSV, which I know is a lot faster kind of experience in the Power Query side than XLSX.
Yeah.
Things you need to look into, just kind of long term. Hopefully you'll be an MDBA like me someday. You'll just be kind of championing the language more and more. But really appreciate kind of having the time to talk about this topic. It's just so great.
Yeah, this has been a lot of fun. Thank you, everybody. I think we're going to... this is the end of the Two Alex show. And Alex, I don't know if you probably need to take off and get some chores done, mow that lawn.
Yep.
So I'm going to go ahead and switch over to just me. And have a good one, Alex. Let's... Okay. Well, if you were interested in sticking around, I'm going to tell you a bit what we're going to be talking about, or what I'm going to be talking about in this impromptu bonus stream about data modeling. So I've got a data set that has 7 billion rows in it. And what we've it's got daily data about our. I work for Microsoft Advertising, so about our advertising business. And what we've been doing to make that manageable in our tabular model is using monthly data only. And so we aggregate down and we get down to just, we drop some dimensions and we get down to just, 7 billion. And it's actually can be quite a bit more than that. Our actual, so Bing.com, like if you want to do event level, like transaction level, like clicks and impressions, you can talk about petabytes of data, and like even a somewhat diminished version of that can be terabytes a day. But when we get down to just the dimensions that we really care about, and daily, not hourly, just daily, it's the data set that we've been working with is 7 billion. But that's big to put. So we have an A6, so we have 100 gigs of memory that I can use to share it a little bit, but mostly I can use a good portion of it. But that's too much for even that. And so we've been aggregating down to monthly, and that gets us down to like 150 million rows of monthly data. But when you're doing monthly data, you can't really look at day of week seasonality, and so lots of folks really want to look at daily data, and they're really interested in daily data for forecasting. And for forecasting, what you really want to know is what happened last year, day of week aware. And so you don't just need the last like 30 days of daily data. You really need the last 15 months of daily data, which is a lot. It's really a challenge for us. And so what we're trying to do is build up a composite model, right? Christian gets up on the stage and demos trillion row, clicky, clicky, draggy, droppy, and I'm like, I'm actually going to try to do that. And looks like my camera just power cycled. That's interesting. Hopefully come back. So we're going to try and build this composite model where we have, I don't know, 100, 300, 500 million rows in memory. Right now we're up to about 30 gigs of cube size with about 500 million rows between two tables. And then a series of aggregates, and then in direct query, the whole 7 billion. And if it works, I can absolutely throw a trillion rows at it. So we're going to try to do that. To make that work, though, we've got some interesting data modeling challenges, because that's not the biggest issue that we have. The biggest issue that we have is that we also have dimensions on a timeline. Pull up Excel here and switch to sharing my screen, and I'm gonna just talk through what we have. So we've got date, and then we've got a series of facts, and then we've got attributes of those facts. And there's sort of two classes of attributes. There's attributes that are tied to the transaction. So like when a click occurs, we know what country the person that did the click was in. We know how we billed the user, whether the transaction was in fact a sale or a refund. And then we have customer accounts, which is our most, well, not our most granular way, but the granularity I care about in terms of who bought the ad. And those attributes, there's a whole long list of them, but the account has, customer location, segment. Let me make a list. Location, segment, vertical, create a date, and then in this, since this is advertising, many advertisers use agencies. So we have agency, we have agency location, we have a bunch of attributes, and then we have sales team. We assign at the account grade, and so in addition to agency, we also have advertiser. So an advertiser can have multiple accounts. In fact, they usually have many accounts. And we assign sales teams at the account grade, and there can be up to 17 people, including managers. So this is a many-to-many relationship between salesperson and account. So we've got a number of sales functions, and they've got managers, and so this can be a tricky one. And a bunch of these change over time. Not so much this one, but these ones in particular, from month to month, they change. Someone goes out on paternity or maternity leave. We assign a new salesperson to cover. Every so often, we redistribute customers. Customer signs a new, and the really big one is agency. Customers go out and they sign deals with, they have a contractual relationship with their agencies, and those change. And they change on their schedule, not our schedule. And it turns out the way we have our business set up, agency drives a bunch of these other properties. Especially agency location, but it has an impact on sales team, has an impact on our view of segmentation. And so these properties have one value per month. And there's a lot of accounts. And so I have a dimension that has different values per account month. So traditionally, the way that you might model this in a star schema is if we come back to here, let me take this and transpose it up here, is you might have all of your attributes that are on the same timeline, just in general, in a star schema, you're just going to have one table with your fact and then dimensions around it. And so if I have, 120, 20, and I'd have values for all of these, and this would be A, and then here I'm going to have, 21, 20, 20, and this would be B. And so every fact date has only one and only one account, so it has one and only one value for all of these, but they're not correlated. So each one is going to be on the fact table. However, the facts, so the way that the data gets loaded is every day we get new transaction data from the last day, and we aggregate that down to the day. And so we almost never have to go back and update past days. Every once in a while we do, but it's like once a year, once a quarter, depending on whether or not we make any mistakes. And so if you're doing an incremental load strategy here, it's like refresh the last month and keep the last X years. And so it runs pretty fast. Especially at the monthly grade, because we just have one row per month and all these other attributes. However, these attributes don't change that way. So we don't always hear about these agency changes when they happen. The data isn't always correct immediately. Sometimes our sales excellence teams need to go back and be like, oh, the agency changed and you didn't tell us. We need to go retroactively change. And so the way the rules in our system are is that all of these values, well, not this one. Let's do some rearrangement here. This one's sort of a special case. historically has been immutable, like the account to advertiser relationship is fixed, but in better effort to match Google, we're changing that. And so this one's starting to become a slow changing dimension. But all of these, they're allowed to change in the past. So the folks that manage this data can go in and say, hey, I know that we received a signal from the agency that on, let's just add some more dates here. Yeah, that's good. That, we've got, this was with agency 1, and then on this day, they changed their association on our platform because we've got tools, so they actually do want to tell us. But we actually go and talk to them and be like, actually, they didn't sign the contract until, or they actually changed agencies all the way back here. And so they'll go back and restate the data into the past. And in our system, they can restate any time in the current fiscal half can be changed at any time. So if we were to continue dragging this down, I've got blocks, and when I'm in this period, any date can be changed anytime while I'm in that period. And then the same for this period, and the same for this period. And so my incremental refresh, let's do, my incremental refresh for this data needs to be refreshed the last 6 months, or it's actually like the current half, but Power BI incremental refresh won't let you do that. So it needs to be the last 6, and it's actually 7 months because there's a little bit of overlap. 7 months, and so refresh 7 months, keep the last X years, right? And remember when we were coming back here, refresh the last week or month, keep X years. So when I combine all of this onto one table, I have to use this rule. But if I want to keep a bigger version of this table, having the performance of incremental refreshing a larger table is really a non-starter. So like the 100-ish million row aggregate that I use for monthly revenue, linking these together is not such a big deal. But if I'm going to do the 7 billion row version, putting this data on this table, and now I have to refresh, so much more of this table, that really starts to pay big costs, not just in my Power BI performance. This is going to be direct queries, so it's not refreshing in Power BI, but we'll have to refresh it in Databricks or SQL. The refresh performance really starts to matter. Like I've now tied together these really different cycles. There's one other requirement that we have that drives, us using a somewhat different data model structure, which really gets to the heart of the problem that we have. So there's a number of ways that you might ask questions about what is the revenue of that, like what is the revenue performance of that person, of that segment, of that location, of that vertical. And invariably, right, it's what's the year-over-year growth. That's the most common question. And we've got all these attributes that are changing, right? So all of these change over time. Do you want to know the performance of a customer from day, how do you want these attributes to change over time while you're changing this? So one way to look at it is, for all the customers that are in my book today, how have they grown over the last year? that is a really good way of measuring what happened, or like that's a really good way of getting an idea of what the accounts that you currently have in this category might do in the future, right? But it doesn't tell you anything about what that category did before, because before it had different accounts. And so if you want to say, hey, salesperson, how much revenue did you generate? You can't use the current definition. But if you want to say, hey, how much growth? If I use this full changing over time, I can't compare the accounts that I have on this day to the accounts that I had on that day and say those, like, it grew X amount, because I'm not comparing even close to the same accounts in a given category. So depending on the question, people want to handle this differently. So what a really common approach is, the way that we do this, is we take all of these columns and we have a whole nother copy of them that are just the current value. And so depending upon whether or not the data is current, or whether, depending on the formulation of the question, you either use this attribute or you use this attribute. So that's great. But now these data change every single day. And so again, they can't go directly on my fact table, because now I'd have to refresh the whole table, which is really a non-starter for us. Now, fortunately, all of these attributes that change over time are single attributes of the account. So one account has one and only one value for all these properties. So actually, if I just have these rows, all these other values I can back into from the account plus the date. There are other approaches to handling the timeline. I'm not going to get into them, but we have several. So how do we solve this problem? I am going to stop sharing my screen and pull up a diagram. And, oh, it's not on my Stream Deck. And then we will talk about some of the ways that we solve this problem. And then we'll finally get into the problem that we're building toward, which is how do we adapt what we've already done to accommodate daily data? So I've covered a lot so far. While I'm pulling this up, are there any questions or thoughts so far? I'd love to hear what your thoughts on how one might solve these problems are. Let's see in the if there's any feedback in the chat. Yeah. Okay. So let me share again, and I got to keep OBS open. That's the problem. Yeah. So, Mark, you're starting to get into the right ballpark. So here, and actually, let's just make an even simpler thing. So we've got, and you can see we've got multiple layers of revenue, which we'll get into. But here, this is the most commonly used fact table. And I've got account attributes. And if you look at account attributes, it's just got IDs for all of the properties we talked about, and a bunch we didn't. And these attributes relate to tables, so we'll just use segment as an example. Relates to this table. And so here, and then we have the same thing for, where is it? Current account attributes. I have another whole other table that has current account attributes, and I have inactive relationships. And so depending upon the formulation of the question, the measure will invoke this inactive relationship in order to change the filter path. And now these tables This one, I can use incremental refresh with the 6-month policy. This table, I can just refresh every day. And this one, I can use my super tight refresh policy. So what's going on is that this table has 1 row per account. And this table has 1 row per account month. And this table has 1 row for every account month and other attributes like transaction type that occur where there's actually a transaction, right? So lots of accounts are inactive. Every business has a churn problem. So here we just have every account, whether or not it's active or not, because people might want to look at that. And in fact, even here where we have every account month, because we have a churn problem and folks want to measure our churn problem, this is also plays double duty as a fact table. And so we have a customer states that measure whether a customer has churned, how long it's been since they churned. And so here we have a row for every account month, which means this table is 150 million rows. Now, for real. In Power BI, in our premium capacity, we have a dimension table that's 150 million rows. And sometimes we relate it by a many-to-many relationship table to another table with 250 million rows. It's not recommended. This is for, so how do we propagate dates? We're starting to get into the crux of the problem. So the default for that first timeline where when I pick a date, I'm looking at the attributes for that date and the revenue for that date. What happens is that the date table filters this table. And this has 1 row per account month. So when I pick an attribute, I get a set of accounts. When I pick a date, I get a set of dates. And then this relationship comes across using, propagates all of that data down to here. So when I activate my inactive relationship over here, I also activate this relationship, and instead of getting, I directly filter the dates here. And then with this many-to-many relationship, if you wanted to pick, let me just bring in this other date table. If you wanted to say, hey, I want to say for the state of my segment at the start of my sales period, what was the performance at the end of my sales period? That's where you could use this many-to-many relationship to choose 2 different dates that are independent from each other. Going to want to get a good book while you run those queries, but we wanted to make sure our users could, because that's a really insightful question, as opposed to, hey, for the customers I had at the end of the sales period, whether or not I actually did any work on them during sales, I want to know how they performed. So, and especially when we make changes, like we have been known. You might have heard Microsoft likes to reorganize. We're not immune from that, and that gets sort of tied into a segment. And so when we have changes like that, sometimes we want to assess, like, hey, how did this transition affect our performance? How did customers from one category perform in the new categorization? Like those questions are super common. Okay. So we've covered how the current world works. And you'll notice that I said, hey, this is account month, and it propagates both. Well, obviously in Power BI, we can't have 2-column keys. And so we have this account timeline ID. And that has it's a surrogate key with 1 sequential value for every account month. So not only does this table have 150 million rows, it has a column with 150 million unique values. And so if we were to open up in Vertipack Analyzer, which we'll do in a second, actually, rather than doing this, let's come over here and just hit these 2 buttons. No, for Dex Studio, we actually need to connect to the production model here, and we're just going to kick off Vertipack Analyzer because it's going to take a while because the model is pretty big. But what we're going to see is that this one column is 25% of our 30 gig model. Just step back and let that sink in. One column in this model is 7.5 gigs. I think I did that math right. Yeah, 7.5 gigs just for this one column. It's almost a large size model all by itself. And that means it's, the performance isn't great. It could be smaller if our folks didn't want to know how many customers were churned in a given month and how long they've been churned. And so we've been thinking about breaking that data out into a separate table so that the revenue queries aren't affected by having to have all these inactive accounts, because there really are a lot of inactive accounts. Before we added them in, this table was quite a bit smaller, like maybe 30 million rows. But now we have two tables that are really big. And so I haven't made up my mind on that one. That's not really the question that we're going to get into today. What we're going to get into today is how does this work when we have daily data? So when we first started with this table, the first design that we did was we were like, okay, most of the time, these attributes don't actually change. Yes, they could change in any given month, but they usually don't. And so rather than having one row per account month, we'll have one row per account state. And then we'll have dates down here, and then every unique state of attributes that an account could be in we'll get in a row. And it'll be quite a bit smaller. There's only like 15 million different states, even when you include account ID. So most accounts have only been in a couple states. And that even includes assignments, which I talked about a bit before. The way that we handle assignments, because it's many-to-many, is this account team ID is a surrogate key that describes every account has multiple salespeople with different managers, and there's different properties that salespeople can have, like role and whether they get the full credit, whether they're on maternity leave. And so we take all of those attributes, and for every account, we make basically one key for each unique state. So most accounts are assigned to the leader for our unmanaged segment plus his managers. And then some accounts are assigned to, a salesperson and an account executive and a technical account manager and a sales insights manager and a global, so we make one key for each one. And so there's only about 17,000 different states, whereas if we had like a table that had account month person, it would be even bigger. So that works really nicely, but it is a many-to-many relationship, and this is an example of where those really pay off. But let's get back to our original problem, which is, so we started off with this having one row for every state per account. But what we couldn't do then was propagate the date, right? I could pick a date, and it would give me, how does, once the date comes in here, I don't know, even if I have the start date and the end date, I don't know which date on this table. So if I filter with this table to a particular date, I can get the attributes. But now this propagation doesn't know what date it is anymore. I'd have to propagate from this table down. And so we get an ambiguous filter path. There's no way to have one table say, hey, give me the date, and then give me the attributes here, and then give me the same things here. You could maybe use like treat as to create a virtual relationship between two date tables, but I would be really nervous to use virtual relationships on time intelligence. The most common query patterns, some of the most complicated query patterns, really don't need the performance hit of a virtual relationship. So that's why we went to the one row per account month. And so when this filters here, I know what month it is because that's encapsulated in my key. I don't know. Does anybody see where we're going here? What's going to be the problem when we go to daily data? I'm going to take a drink of water while Any ideas? Well, too many keys is a problem, but the real problem is that here I pick a date, and here that gets translated into a month, and now I know a month. That's fine because I only have one row per month for my transactions. But what if I have one row per day? This relationship doesn't know what day it is. It just knows what month it is. And we already established that this key that knows what month it is 25% of the model. So if I take all of this other data and mirrored it to have one row per day, none of these other columns would get any bigger. The number of unique values would stay the same. So here we've got our Vertipack analyzer, and we can now say, oh, I didn't look at the right model. Okay, I'll move that off to the side. Well, this one key is already 25% of our model. The rest of these columns, if I were to increase the number of rows but not increase the cardinality, they don't really care. It'll get a little bigger, especially because we're adding partitions, and so there'll be copies of data across partitions, but for the most part, the data size will stay the same on everything else. But this one, if I wanted to include the date as I go from this table down to this table, not just the month, but the actual day, this key needs to have enough granularity to encode that information. And so now, instead of having 150 million unique values, I've got 600. I don't know, what's 30 times 150? It's a big number. It's too big of a number. It's, I don't know, 30 times 150. That's the math that we're going for. It's 4.5 billion. On one key on one dimension table. Even in direct query, because even in direct query, you still need to have these nice one-to-one relationships. You can't have multi-part keys. Plus, this dimension table, even though the fact table is going to be in direct query, the dimension table needs to be in dual mode, because when I don't have my queries at the day grain, I want to propagate my filters, right? And I suppose I could have this dimension in direct query and have another copy of this table that's in memory, that's the way it is now, and use logic to switch back and forth, but I don't want to do that. The code complexity there starts to get really high. I mean, maybe that is the best solution, but I wanted to talk through this and see, is there a better way to have account attributes that are on a timeline that's synced to the fact table, that's on a timeline, where you don't need to have a key that has one row for every row of your account attributes table? Well, I've talked through the whole problem, and I don't have any brilliant solutions. So while y'all come up with brilliant solutions for me, I'll continue the little bit of tour to show how we do what we do. So first thing is, let's bring up in Tabular Editor. which is safe. There's not going to be any data that you see, so that's great. And we're going to look at performance measures. And actually, let's start on our fact table. So monthly revenue, L1. Wow, that's a lot of measures. So how does this work? So I've got billed revenue. This looks totally normal, right? The sum of monthly revenue. And then we go from here. This measure is hidden from users. They'll never, ever, ever use this measure. And now we have another measure. This looks more complicated. Let me fit this to my zone and zoom in a bit. Here, can I zoom this? Yeah. So what this does is there's a table called timeline method, and it just has it's an interdata table, and it just has these various values of full timeline, snapshot, current, separate dates. And what's going on is this is how we switch between our timeline methods. So we use relationship to say, hey, if they want to do separate dates, you need to go activate that many-to-many relationship and activate that other date table. If they want to use current, you need to go activate the relationship with the current account attributes table, and again, move the date table around, and so on and so forth. Okay, so that solves our relationship problem. But guess what? We also have aggregations. So if we actually go, that measure is also hidden from users. And we build revenue, here we have our aggregations. So we have and these are all in memory, so we can't use built-in aggregations. Plus we have ambitions to use fill CMarks, crazy DAX, like horizontal ags, where if you have, like, say someone queries for the revenue for the last 47 days, it'll go and say, hey, from your month table, I'm going to get 1 month, and then from your day table, I'm going to get the other 17 days, which can really improve your performance on these weird time periods. And one of the things I really want to do with daily revenue, we talked before about trying to forecast, and that means you want to do last year and you want to look at the days of the week, because weekends are really different from weekdays, both in just like the how much activity there is, but also like the types of queries people send. And so you don't want to look at the same performance the same day last year. You want to look at the performance the same day of the week last year. And so you want to do a day of week aligned calendar. And so you're going to, that will generate lots of queries where you have like a month, but then a couple extra days here and there, or a chunk of months and a couple extra days. And so those horizontal ags are really going to help us out there. But we need to do DAX aggregations. We can't just rely on the built-in feature. So we have, if any of these tables are filtered, then we have to go to our biggest table. And then if any of these tables are filtered, we're at the customer grade, and we have to look at that account, the L1 table we've been looking at. And then if they've only filtered by account team, there's a smaller ag that only has 1 million rows that they can hit. And these other filters also pop you into the detail. And then if they haven't filtered by any of these things, there's a group of tables that aren't even in here at all. We've got a table that only has 100,000 rows that's super, super fast. And so what's going on is, once we know these conditionals, just like if this is true, then you have to go to query this table. And if this is like all the way down, and all of these measures have that use relationship in them. It's really complicated. So in another one of these little bonus streams, I want to come up with I've got like a note outline on how we can use calculation groups to consolidate some of the logic, so I don't have to write that user relationship code in every single measure, and I don't have to write this is cross-filtered logic in every single measure, because I don't just have billed revenue, I have clicks and impressions and spend and invalidated clicks and invalidated impressions. And I have other measures that don't have aggregations but do have use relationship shenanigans. So that's what's going on in the model. And our VertiPack analyzer is done. Oh, I have to use, I have an ultra-wide monitor, and so I'm using Power Toys to create a zone that's matched with the aspect ratio that is a zone that's matched with the aspect ratio of the stream while still using my main monitor. So anyway, here we can see, I wasn't joking, 250 million rows. Cardinality, it's the exact same because the table has 1 row per account month, and this key describes the account month. And you can see that that adds up to 25% of the database, and if we go over to summary, 30 gigabytes. And then we have the corresponding key on the account, the fact table. This has more rows, but most accounts, maybe not most accounts, but many accounts are inactive most of the time. And so the cardinality is way lower. And as a result, the column is 5 times smaller. And then this is a column that we super need to optimize. So how long does it take to upload this thing? So that's not at all how it works. I'm going to stop sharing for a second while I bring up some stuff that has a potential to show stuff that I really don't want to show. So let me let me come to advanced editor, bring this into my share zone, and Alex is going to give me a super hard time because my DAX or my M isn't formatted because it's almost all auto-generated, and nope, that's not the. Is it Control 3? Yes, using zoom it. So what's going on here is we have incremental refresh set up, and then we have this row limiter. And so when we upload to the service, this parameter is set to 10. So this PBIX file that we're looking at here with all this data, it's like a megabyte. It takes no time at all to upload. And then after we publish it, we change this parameter to be 0. And when the parameter is 0, instead of having this first in filter applied to the table, we just return the whole table. And a lot of our tables are like that. So let me come back out of that. And so when we upload the file, here, the file itself is a megabyte. And then when it gets loaded to the service, we do incremental refresh to create all the partitions. That doesn't take very long. Then we change the parameter, and then we have to refresh the whole model. And that takes days, literally days. We never ever do a full refresh of the model. Lots of the small tables refresh individually, but our fact table and our account attribute table do incremental refresh. And when we have to restate one of them, we go partition by partition, and it takes about a day. If we had to refresh both of them at the same time, well, we just aren't going to do that. So now part of that is, you may have noticed when I had the M up, I'm not going to bring it back up, but our data source is Dataflows. Just like we were just talking about in the conversation, we're using external CDM folders that are attached in Dataflows, and so the data is loaded in. The CDM folders are partitioned by date, And so one would hope that when we're doing incremental refresh, it's only downloading those dates that we're refreshing. However, there's no diagnostics to check whether or not this is happening. And there's no documentation that says this is happening. Anecdotally, I've heard people posting that it does and that they've sort of checked it out. But I'm not going to take the time to figure it out. The refreshes work. And so what we're going to do in the future is change all the data sources to be pulling from Spark. However, when we recreate all of these tables, all of these relationships are destroyed. And so somebody on my dev team has to go through and one by one recreate all the relationships. And my camera just overheated, so we're going to go no video for a little bit. But so let me just hide the little black box and my name. So with switching our data source from CDM to Dataflows, we've got a ton of work, and it's really hard to do that work while we're continuing to update the model. And so we keep putting it off. But we have to do it because we're going to do this daily composite model with daily revenue. And in order to do that daily revenue, we need dual mode tables, which means the tables have to be recreated and the tables have to be, what's the word I'm looking for? They have to be on the same source as the direct query is going to be, because to do the direct query correctly, it has to be able to pass the filter predicates upstream when necessary. So we're working on that. It was definitely a mistake to use CDM folders to start with. I think we sort of covered that in the stream. So what's going on in this spiderweb model is, I'll try and talk you guys through it. These are our fact tables. And then all of these fact tables are related to each of our 3 account attributes variants and our 2 date tables. And then all of these tables across the top and this one are related to the account attributes tables. And then down here we have attributes that are only related to particular facts. So which platform the ad showed up on. These ones should be up top. They are not where they're supposed to be. But then we also have these opportunity and feature adoption. They have their own fact tables, which are around here somewhere. It looks like the diagram got a little screwed up. Up in this block here. And you'll notice that there's not a single bidirectional relationship anywhere in the model. There is some code that sometimes invokes bidirectional relationships. I guess we have this. This is a new table. The team was not supposed to do this. What they were supposed to do was create a surrogate key and put the surrogate key on the dimension. And so we're going to need to update that. But in general, we don't use any bidirectional relationships. And this one is not quite so bad because it's 1-to-1. Those are going to be faster than the traditional many-to-one bidirectional, but nonetheless, not what we want. And also, like, the account table doesn't change over time. This theoretically could, and so we'd want to have it. Well, maybe we don't want it to change over time. That's an interesting discussion because the properties that we use to calculate this change over time. However, it's about the customer's business model. And there are many-to-many relationships. We've talked about a couple of those, and we'll look at those. And they're very intentional. The properties that build this table change over time. However, what they describe is a customer's business model. And customer business models really don't change over time much. So, so many-to-many relationships. We've got some. So we talked already before about this separate dates mode. And that uses a many-to-many that's strongly discouraged. This one's too hard to see. But what we do have is if we bring in this, and even if we bring in current account attributes and we look at assignment, this is many-to-many. So, but it's actually not very bad at all. So let's pop over to Vertipack Analyzer and let's look at the table assignment and see what we have. So we have account team ID. The table here has 500,000 rows, but its highest cardinality column is only 17,000. And that cardinality is the same if we look at this table. If we look at account team ID, 17,000. So this computer has 48 gigs of RAM. But again, this model is only on the service. This PBIX that we're working in is 1 megabyte. And so if we look at Task Manager here and performance, you'll see that like I have a lot of memory consumed, but it's Chromium. It's not like analysis analysis services is not using, well, it's using a lot of memory, but yeah, because all of these tables have only 10 rows in them because we've got that row limiter we talked about. So yeah, it's a many-to-many relationship, but the cardinality is pretty small, and the alternative to modeling this would be, because we have multiple salespeople on any given account, would either be to like make some sort of assumption about all the various functions a salesperson could be in, and then if we ever had a case where we had two people sharing a function, like the whole schema would fall apart. Or we need to have like an account month dimension because these change on account month, or like, yeah, it makes everything else really ugly. But by just doing this many-to-many, and maybe we could use the bridge pattern instead of the many-to-many pattern, but like the performance is fine. We haven't tested the trade-offs. That's something we should do because sometimes the bridge pattern is faster than the many-to-many. So where else do we have many-to-many relationships? Let me just look through really quickly. We have many-to-many relationships in our row-level security. That is more painful. It's basically the exact same thing, though. We have a list of people and the accounts that they match up to, and we have data that says, hey, these people, based on their security roles, they can see these rows of quota. And so that's another many-to-many relationship, and it would be really painful to have this not be, because we'd have to have one row per person fact, which just makes handling the adding of the facts super bad. So, yeah, we don't do that. We just eat the performance cost when someone wants to look at quota, which they should do as sparingly as possible. So, that's our introduction to the model. I think we've covered everything that I wanted to do in terms of discussion. And so let me just make a new note page and let's talk about some options. So, options for daily revenue date. And I'm probably going to end up sending this recording to my dev team. So the first option is that we could have a account day key to prompt to you. The advantages here is it uses the current model, 30x more rows, 5 billion. Okay, so that's one option. The next option is have two account attributes tables, one with account month key in memory, one with account day key in direct query. Same memory usage. ETL still has 30x more rows. Tax gets more complicated, but not maybe we'll talk about more on this question here. Virtual relationship. This actually works. Okay, so does anybody have any other ideas? Yeah, I don't know that there are any other options. So let's talk a little bit more about these two, and then we'll probably wrap up unless someone has a brilliant idea to explore. So let's first talk about the virtual relationship. So what that would mean is that we would write something like, well, first of all, we'd be using that many-to-many relationship. So yeah, that's what I mean by virtual relationship. Treat as. So what this means is we're going to have let's turn the highlighting off. Two date tables, one hidden. Anytime you filter date table number one, the measure uses treat as to apply the same filter to date table number two. Date table number one selects rows on add which passes those rows to the fact on a one-to-many. Nope. Well, on a relationship, we'll come back to that, that only encodes account. Row per account month. Okay, so this here, even though it only needs to encode account, but to make it, let's just reorganize that. One-to-one nanny relationship. It needs to be a account state unique or account month key. So we could go back, instead of having one row per account month, we could go back to having one row per account state. So if an account has the same state for several months, it would just have the same Well, no, it still needs to be account month because our date table still needs to know, like our date table must have one row per date. It's really going to be a nightmare if we don't. I guess Phil has done some blog posts on ways to challenge those assumptions, but I really don't here. So this doesn't reduce the cardinality of what we already have. So then the date table number 2 passes the exact day to the fact table via. So this might work. Testing this is going to be super time consuming, but we can do it. Okay, so let's talk about what this entails. What this entails is so before, when we went through our measure, we had build revenue, checks ag level, and then we had revenue LX sets filter paths based on timeline method. And then we had base revenue X finally actually adds the numbers, right? And what we would have to do is when we hit the direct query, we would have to use, so in this mode, and I'm going to say that it really does increase it. Use jumps through day account day dimension. Okay, so now let's see. Is everybody still following with these trade-offs? Let's talk about what this entails because it's super messy. So when we were in here and we were looking at our what am I looking for? I'm looking in this one. When we were looking at this, when we set our use relationships, we only have to change 2 relationships. Right? We have to change our date relationship, and we have to change the relationship between the account attribute table and things. So coming back to our diagram for this, we just have to choose whether or not, let's move this over. We have to choose between these 3 relationships, or it's actually, there's more than that, but we have to choose between these relationships and between these relationships. Well, these 2 relationships, and that's it. However, if we're going to change this table, we may have to change all of these relationships. I don't think we do. I think we just have to, again, change the active path. But we'd really have to test this because, again, what actual queries get sent is going to really matter because we have to do this in direct query. And we're going to try and do this against Databricks. So it's not guaranteed that everything's going to work the same way that people expect from their SQL experience. Now, if necessary and performance is not what we want, I'm fully prepared to spin this up on SQL data warehouse and using that. Yeah, so Fernando, again, like we have the nice small model, which means I haven't created any relationships in this, but just playing with this it does seem fast. I think that's because while the model is small, I do have a very powerful computer. This is, not your laptop. And so it does do a nice job of rendering stuff. And in fact, it does a really nice job of rendering stuff, even while streaming. Yeah. But let's get back to what we were talking about. Before we do, let's just keep up on this conversation about computer performance. RAM, RAM only matters when you don't have enough of it. As long as you have RAM from the last 5-10 years, it's going to be fast enough. And you only run into problems when you run out of RAM. And so because my model is pretty small and I do have plenty of memory and I don't have a lot going, like normally I see several gigs here, there's no problem with running out of memory. Teams often uses more memory than this. Edge usually uses more memory than this. Chrome uses even more memory. But as long as you don't run out and you're not paging to disk, performance is unaffected by how much RAM you have. What then really matters is your single core CPU performance. Most things aren't super well multi-threaded, especially Power BI. It can go multi-threaded on some queries, but the stuff that you actually that feels slow is single-threaded. And so having a really fast CPU that's running at almost 5 gigahertz really helps a lot with your performance. Where does the GPU help? Well, my GPU is encoding our stream right now. And so that's why my CPU is staying nice and low. And because this GPU is ridiculous, the stream encoding takes a lot off. So normally if I was streaming while doing this, the CPU would be struggling, and we might see that in Power BI. But I'm able to use my GPU for that. GPU does not matter at all for Power BI. Maybe it matters for rendering the screen, so when you drag things around. But even most of that's going to be happening in Chromium, because this is just Chromium underneath Power BI. If you come into the processes and look at Power BI desktop, browser subprocess, this is Chromium. Yeah, so right now, the Microsoft employee version is we just get each month's release a week early. So it's not really any different. If anything, it's a little worse because I haven't fixed all the bugs. Yeah, and Theo, I do have my CPU overclocked a little bit, right? The box speed here is 3 gigahertz. Well, we're running at 5. But anyway, back on topic, and we're going to wrap up really soon here. When we run this query, if all we have to do is use different relationships between the attribute and the ag, while, like, we already have that DAX for every different permutation. It's just we'd have one different permutation that goes through our daily dimension rather than through the monthly dimension. That would be fine. If, however, the use relationship has to remap all of these relationships, that's an order of magnitude more code than we were writing before. And every time I add one of these, I have to add code. And that's the real killer. It's that this code has to be updated. Everything that you have in your model that has to be updated when you change something else in the model, that's the real cost of the aggregations. Is if you come into performance, where is it? Performance measures. If we come into build revenue, anytime I add a table and I don't add it to my ags, I have to add it to this list. That's a real technical burden, which is why I want to do calculation groups to centralize this logic. But so, like, that's the types of costs that I'm really leery about changing, because now my dev team, which, like, they're not super senior Power BI developers, like, they have to remember this stuff, and yeah. So that's the big challenge. So anyway, we've explored our three options. This one we're not just doing. Like, that's not an option. You might be able to. I'm not really an expert in tabular editor scripts, and I don't know. It would be complicated because depending on what you added, it would go in different categories, and so you couldn't just, like, you could probably analyze the relationships to figure out where to put it, but, like, I don't want to do that. So anyway, we've explored our options. We're just going to have to performance test between the two of them, which means that on the ETL layer, we're going to have to build this table. I guess we could test this first and see how this works, and then build this if necessary. Problem is, well, we just don't know how the direct query is going to perform at all. We're going to see if it's. We know what acceptable looks like. So, which actually brings me to the last thing that I wanted to chat about here. Let me go back to my video for a second, and I'm going to bring up a report, Power BI, and let's look at one. Well, let's see if we can look at this. I don't think there's anything sensitive in this report, but let's look at query durations for this model. Okay. So, what do we see in the Power BI capacity consumption report? Can we nope, that's not going to work for you. Nope. Can we do this? Is that legible? Can I see in the chat whether or not this is legible here? No, the problem is if I press F11 with fancy zones, it's not going to work. I guess I'll use zoom in. So we get a couple pieces of information. The average query duration and max. Average is totally useless because this max is so high. And if someone is able to connect to your XML endpoint and write big DAX queries to pull out tables, this number is going to be really high. More interesting is this query distribution. So we see that 10% of queries take more than 30 seconds. And another 15% of queries take more than 10 seconds. And another 15 take more than 3 seconds. This is really not acceptable. We used to have, until a month ago, we would have 80% of our queries under 1 second. And that's really what we want to see. And so when we think about, do we have enough aggregations? Is direct query performing? Like, I don't want to go any worse than this. This is sort of like worst case scenario for acceptability. But like, that's really what I'm going to look at when I decide whether or not we have. Yeah, Laura, I did end up using Zoom It, which I always forget about. And then you can see the hourly distribution. That's somewhat useful. One thing we can see is that we're really not having memory issues, which despite the big size of our model. Yeah, Mark, this episode will be in YouTube. I try to take some timestamps so that like there'll be breaks to it. We'll see if I succeeded. The other big thing that we look at is query weights, and this tells us whether or not we have enough CPU cores. 28% of the time there's a wait. That's not great. But if we look at the wait durations, only a few people are waiting more than a few milliseconds. This is much worse than it used to be. We've really started to experience CPU pressure in the last week or two. Usually we see that our average wait time, our max wait time, I mean, this is okay. Our average wait time is imperceptible, and our max wait time is under a second. But we're seeing lots of queries having 100 milliseconds added to the query time. And when we want, in general, our queries to run in 100 milliseconds, waits that are sort of, well, half of 20%, so 10% of queries, their time is added, maybe doubled, based on the weights. That's not super great. And we see that they're highly concentrated in just a couple spikes. So we have enough CPU. So that's okay. But it would be better to see these a little bit lower. So that's what I'm watching when in terms of, hey, do we have enough capacity? And then like the memory consumption. So if we come down here and look at resource consumption, like we have a lot of memory. We're not really using it. Usually, and folks end up buying more premium capacity because they run out of CPU, not because they run out of memory. And that's why, like when we were talking about per core performance, that's really what we're talking about. Because like, yeah, we've got 100 gigs of memory, and that means I can make the model bigger. But what I really care about is, are my queries running fast enough that my users aren't waiting for the next person in line? So anyway, I think we're going to wrap up here with this discussion. But thanks for hanging out and listening to me talk through this problem. I don't know that we came to a good solution, but at the very least, we figured out the answer. So I'll turn my video back on, see if it's not overheated. Yeah, so Fernando posted something about are all our sources relational? Yeah, so all of our data is in Azure Data Lake, and we're putting it into Databricks. I don't really know what a graph schema would work like. I don't know how Power BI would handle that. If you wanted to write something explaining that, that'd be really helpful. I don't really see how to do that with one-to-many relationships. But we are definitely open to trying alternate databases to make this work. Because if we can make this work with the 7 billion rows, I would love to go to hourly data. I would love to go to within campaigns we have, or within accounts we have campaigns that hold account ads. I'd love to let our people get into, specific ad classifications and not just customer classifications, but now we're starting to talk about many terabytes of data, which only works if direct query is super good. If I can make a really good experience, I can get the money for the resources, but only to the extent we can come up with really good experiences. So anyway, that's going to wrap us up here. And thanks for hanging out with me. And we'll talk in 2 weeks. I have no idea what Alex and I are going to talk about then, but I'm sure we'll come up with an interesting topic. And have a good day. Bye.